moving into chapter 12, the first assignment that I have for you is, or first part lesson of this is 12.2, which is rational expressions. In classroom, your book has been posted. And during this lesson, as you access the book, you'll learn how you should be able to say that I can identify values excluded from the domain of a of a rational expression, and that I can simplify rational expressions. Okay, so you're looking, the key part here is that we're going to look for excluded values in a rational expression. So we're going to look for the things that cannot make the expression true. And then we're going to learn how to simplify rational expressions. So first, let's look at the example in our book, and then we'll look at another one. So if I have 5m plus 3 over the value of m minus 6. When we are asked to state one excluded value, and we're trying to think of something that would make this expression not true. Does anyone have an idea of what would make this expression so it would not be true? Is there any value in the world that you could think of that would make this not true? So when I say the value, it would have to be for m. Cole?
0.
0. Okay, if I had 0, it would make it true. So let's just look at it for a second. You're on the right track, though, okay? So if we take 5 times 0 plus 3 over 0 minus 6, that would be 3 over negative 6 would be negative 1/2. That would still be a valid expression. You're on the right track, though. Austin?
I think m would have to equal 6.
Why is that?
Because it kind of like goes into what we've been doing, because as you could get rid of the denominator, and so
If we got rid of the denominator, if we make it, let's look at it like this: 5 times 6 plus 3, and then 6 minus 6. So I would have 33 over 0. What's 33 divided by 0?
0.
I hear 0, I hear error. So we ask ourselves, any kind of division problem is a multiplication problem also. 0 times what equals 33? There's nothing. There is no solution here. Okay? So Austin's exactly right. We want to make, if our denominator equals 0, or if our divisor, I'm going back to 4th grade language, if our divisor equals 0, then the entire thing equals 0. Anyway, so our denominator, if our denominator equals 0, that is an excluded value. What's kind of weird about this is that we're actually looking for the answer that makes it that it's not true. So our answer to the problem is the excluded value is 6 in this case. So we're looking for the thing that will make it so it's not true. So the excluded value of this is 6. Boom. So let me give you one. 3b minus 7. 3b minus 2. So it doesn't matter. 3b minus 2 over b plus 7. Okay? I want you to think about this. You can even do it in your head. What would make this not true? What is the excluded value in this problem? Don't need hands at this point. Just want everyone to think about it for just a little bit. What would make this so it's not true? No, you got it?
No.
No? Well, okay, so what did I just say over here? What would make it so it's not true?
6.
I know, but what was it? What was the process? Why does 6 make this so it's not true?
So it's not next to the denominator 0.
So we're looking for the value that makes the denominator equal to 0.
Oh, so then it'd be negative.
Exactly, yeah. So it's negative 7 in this case. Negative 7 plus 7 equals 0. And it doesn't matter what it is up top. We're just concerned about this part here and making that 0. Now, sometimes it's going to be harder than something like this. Okay? But if you just take b plus 7 and make that equal to 0 and solve for 0, that's the excluded value. That's the value that would make this whole thing not true. Again, it's opposite thinking. We've always been trained. We have to find the answer. You gotta find the answer. Where is it? Again, there it is. I found X. X is right there. But this is, we're actually trying to find, in this case, we're trying to find B. But B is the one thing that would make this whole thing not true. It's the excluded value, the one answer that would make it so it's not true. Yes, sir.
Well, okay, so I divided by 0 is can't happen, right?
Right.
Well, what was it 0 over 0?
0 over 0. 0 over 0 is different because that's just 0. That's the 1. 0 divided by 0 is 0. Okay? So anyway, in here we could just solve for b. B equals negative 7. I mean, you could do this one in your head, negative 7 plus 7. Once the light turned on there, it's like, boom, negative 7. So this one, you don't actually have to go through this process. Some of them, you will have to go through the process to figure out what makes it equal to 0. Some of the more complicated problems. Okay, so in this case, the excluded value, value is negative 7. All right, so sometimes we have more than one excluded value, and let's take a look at a problem like that. So here I've got x squared minus 5, and I've got x squared minus 5x plus 6. Plus 6. And this is the value that is given in your book. Okay? Or this is a problem that's given in your book, and we'll look at another problem and go from there. So x squared minus 5 over x squared minus 5 plus 6. What do you think, just looking at this? What do I have to do first? Yes, sir.
It looks like you could do what multiplies 6 and s negative 5.
Yeah, you're gonna want to factor. So you have to look and see, can I factor anything on the top? Can I factor anything on the bottom? And you do have to factor on the top. However, I don't know if we're gonna have many problems like that quite yet. I'll show you why later. But anyway, yeah, let's go ahead and factor. Let's factor. This isn't factorable. X squared minus 5. The numerator in this case is simplified like that. What can I factor with x squared minus 5x plus 6? Jasmine? Negative 6 and positive 1. That would make it a negative. That would make it a negative 6 instead of a positive 6. Go ahead.
Negative 3 and negative 6.
Okay, so x minus 3, x minus 2. Okay? So then we have to say anything, it's this value, x minus 3 times this. What would make this so it's not true? What would make this so the denominator equals 0? Allie? 3 and 2. Okay, so if this equals 0, then anything times 0 is going to equal 0. So Riley, taking a look at this. If it's 3, we would have, if x was 3, we would have 3 squared minus 5 over 3 minus 3 times 3 minus 2. And that would equal 9 minus 5 over 0 times 1. And that would equal 4 over 0, because 0 times 1 equals 0. So in this case, if we substitute in for x, 3, this whole thing would not be true. That's an excluded value. Anything else we put in there, except for one other value, which Allie said was 2, anything other than 3 and 2, this would be true. You could make it, you could simplify it, and you could do all the divisions, and you come up with a decimal or a fraction. Except for 3 and 2. Those two make this not true. Does that make sense? Yeah? Okay. And I could do the same thing with 2, but just look. 2 minus 2 equals 0, and negative 1 times 0 equals 0. So our excluded values are 2 and 3. Right, so I want you to try one now. 5a squared plus 2 over a squared minus a minus 12.
I get it already.
Like, can there be problems where there's also like, what if the number used to make the denominator 0 also made the numerator 0? Would there be no solution?
No, that wouldn't be an excluded value.
Yes, so it could be no solution.
If there was only one thing, then there would be no excluded value. Yes, you're correct.
That's a weird kid. Something that Brian is doing over
So,
nah, man. I'm going right here. Cut off. Silence for me.
Boom, boom, boom. Okay, so what do I have to do here first? What do I have to do first? Austin? What?
Okay, the a squared is correct the next day. A over.
No. Those are
No, I'm on the bottom.
you can't subtract those. They're not like terms. A to the second and a to the first. Those are not like terms. It goes back to chapter 8. If that was a to the second and a to the second power minus a to the second power, you could subtract them. But what do I do? What do I do here? Cole's already told me he knows what to do here. Christian.
You see what adds to negative 1 and multiplies to
What are we doing when we're doing that? What is that called? Factor. Exactly. Factor the trinomial. Factor the trinomial. You've got a trinomial here. You could factor up here too, but we're really concerned about our denominator. That's the only thing we really care about. Okay? And kind of. A squared minus a minus 12. What does this factor into? Joel, what do I factor here? What am I looking for? But I'm calling on you because you're spaced out and not paying attention. What am I factoring with? A squared minus a minus 12. What am I looking to do? Come on. Step up to the plate of learning now. Get right up there. Choke up on that bat if you need to, but pay attention. We're factoring. We did this in chapter 9. What am I doing? I'm not letting you off the hook here. If I'm factoring a squared minus a minus 12. Exactly. Okay, so we're multiplying the negative 12 and we're adding the negative 1. Thank you. Now you're ready to swing away, right?
That was terrible.
All right. Pitch is coming in. Pitch is coming in. You can choose. Yeah, what multiplies to negative? What multiplies to negative 12 and adds to negative 1? All right, I'll let you think.
Stripes. Favorite typically slow motion.
Hold on, slow.
I'm giving you all the time you need.
Hey, it is quick one.
Stop talking. That's all of you. Cole, you need to leave. I just said stop talking. Next word. Joel, tell me something that multiplies to 12, to negative 12. I know, you need to turn it on. We gotta go. You got progress in like an hour. I need you to start thinking it now. Tell me two factors that multiply to 12, to negative 12. You have to come over here. Tell me something. What multiplies to negative 12?
-4.
And positive 3. Does that add to negative 1? Thank you. A minus 4.
That's a good job,
Done.
Joel.
Done. I didn't say you start talking. When you're ready to come back in and stop talking, you can find another seat and you can get back to learning. So out there, find another seat when you're ready. Okay, so now that we factored that denominator into a minus 4, a plus 3, what are my excluded values? Samantha. 4 would make it, okay, because we just make this just like before. A minus 4 equals 0. We add 4, A would equal 4. Well, it's actually A can't equal 4, but we're trying to find the thing that would make it so it does not work. And then negative 3 also would make this equal to 0, because anything times 0 equals 0. And if our denominator equals 0, it's not true. So again, our excluded values in this problem are 4 and negative 3. All right. Next, we have expressions involving monomials. In our book, we are given the problem. Yes, ma'am.
When you find the excluded values, does it only work in the version where you have it factored, or does it also work in the non-factored version?
Well, we're going to come to that in a second. But in this case, we can't factor that anymore, so we can't simplify it anymore. So it's okay.
But what about the denominator? Like if you put the excluded values into there, like if you put 4 into there, would it still work? Or
If I put 4 into this, watch. If I go back to the original problem and I put in 4, okay, it's going to be 5 times 4 squared plus 2 over 4 squared minus 4 minus 12. I'm going to erase this. Now, we just said that is something that will make this so it's not true. So if I put it back into this original equation, it shouldn't be true. So I've got 5 times 16 plus 2, and I'm just going to leave this like it is. I guess I could do it. 5 times, that's 50, and 30 is 80, so that's 82. So we've got 82 over 4 squared is 16 minus 4 minus 12. So 16 minus 4 is 12. So I've got 82 over 12 minus 12, which is 82 over 0. And then the same would hold true if I put in negative 3. So you can check your answer and put it back in and see, does the denominator equal 0? And as long as the numerator doesn't equal 0 too, it's an excluded value. If for some reason the numerator equals 0, then it would be true. It would be 0 over 0. Then that's a little different case. So, Got it? Does that make sense? What we're really trying to do is we're just trying to find out what would make in this numerator, in this denominator, so it equals 0. And there's two values in this case. In this case, there was only one thing that would make it not true. There's only one value in the entire world, entire numerical world, that makes it not true. And so that's what's weird about this. We've always been trained our brain to think, what makes this true? What solve this problem? Well, now we're trying to find that one thing that would make it so it's not true. Oh, mind blown, man. It's so crazy. Anyway, moving on. So, next, expressions involving monomials. 7, -7. Monomials. -7 times a to the second power, b to the third, over 21. A to the fifth, b. What's cool about this is we've already done these problems. We did this back in chapter 8, the very beginning of, back in January when it's freezing. But now we can attack these when it's nice and warm out. We can run outside and play and get some vitamin D and run around. But now, I want you to think back to these. Okay? We can simplify these problems. We've got our -7 over 21. We've got our a to the second over a to the fifth, and we've got b to the third over b. Okay? We can simplify like terms. Okay? You can even break this up into pieces. You could say -7 over 21 times a to the second over a to the fifth times b to the third over b. Now, I want you guys to put on your brains, your thinking caps, get going and thinking about this. If I have -7 over 21, how would I simplify that? How would I simplify -7 over 21? Holy cow. Now I want to see your hands popping up because you know this. How do I simplify -7 over 21? Thank you. Now I'm feeling better. Connor. Oh, God.
That would be, wait, so I'm going to simplify.
-7 over 21.
-1 over 3.
-1 over 3. So this part right here simplifies to -1 over 3. Who can simplify a to the second over a to the fifth? Ooh, I like something jumping up here. What does that equal? Jacob.
It would be 1 over a to the third.
1 over a to the third. Remember, knock it off. Just for a little bit, knock it off. Okay? Remember, when we have like terms, what do we do? Subtract. Yeah, you subtract the like terms when we're dividing like that. So 5 minus 2 is 3. There's more on the bottom than there are on the top, so those go here. So another way of thinking of a to the second over a to the fifth. I taught this back in chapter 8. A times a over a times a times a times a times a. Right? And 2 of these cancel out with 2 of these. We're left with 1 over a to the third. So you subtract them. 5 minus 2. Riley, up here. You're off in space. Okay, so what would b to the third over b be, Riley?
B to the third over B.
Yes.
That's it, right?
What's that?
That's what it would be, right? Because you can't simplify it.
No. It's frustrating because I just explained. You can write it out like this if you need to.
Oh, so it would be b squared.
Yes.
Over just b squared.
B squared over 1, or just b squared. Yeah. Okay. Then we can simply just, if you wanted to, you can put it like that. So it's, and simplify it. So you've got 1 times b squared. We would just write that, you could write as 1b squared, but just write as b squared.
What do you mean?
Negative, yes, negative. We put that negative out here, and then 3a to the third. So that simplifies to b squared over, negative b squared over 3a to the third. What makes this, what is the excluded value in this case? What is the one thing that makes the denominator 0?
Settle.
Yes. Well, 3, let's check it. If b equals 3, 3 squared over 3 times 3 to the third, and that's negative. Okay, so that's 9 over 3 times 27 is 81. It's not 0, is it? What makes it equal to 0? 0. 0. 3 times 0 times 0 times 0 is 0. 3 times 0 is 0. 0 cubed is 0. 3 times 0 is 0. These kind are pretty easy to find the excluded value if it's just a monomial. If it's a monomial, it's going to be 0. Okay? But if you don't know what to do 3a to the cube equals 0. Oops, equals 0. And then you would divide by 3. Okay. A cubed equals 0. And then the cube root of a, the cube root of 0. Well, what times what equals 0? 0. A equals 0. Oh, sorry, that's the cube root of a cubed. I don't know why I put 3. A equals 0. All right, moving on, I want to give you one more. Simplify this expression, 32x to the 5th. I want you to write this down, 32x to the 5th, y to the 2nd, over 4x y to the 7th. I want you to do this problem and check it with a neighbor. This is a time when you can talk. But do the problem. What am I missing today?
Wish you were PT. Wish you were PT.
What do I do first?
Simplify.
What do I simplify?
Like reduce.
Okay. What do I do? Tell me what to do.
Break it down. But 32 forward.
Okay.
And then times x to the 5th order. Times y to the 2nd.
Okay. Perfect. So you can break it out like this. If you don't want to do it like this, if you want to just deal with it here, that's fine. I sometimes do that. So now that I'm better at it, I do it just right here. But if you want to break it out like this might make it easier. So continue on, Nate.
32 forward goes to just 8.
Okay, 8. I always like to put 8 over 1 if I'm breaking it down like this.
And then x to the 4th over 1.
X to the 4th over 1, there's 5, minus 1 is 4, more on the top.
And then 1 over y to the 5th.
Okay, good. And then we can simplify that by saying 8x to the 4th over 1y to the 5th, or just y to the 5th. If there's nothing but 1's in the denominator, you don't need to write the denominator. If there's nothing but 1's in the top, you have to write that 1 there. So, but anyway, so this is 8x to the 4th over y to the 5th. What's our excluded value? Or values? Well, 0. So, yes, anything times 0 equals 0, so good. All right, where am I going with this? That's that type of problem. Finally, we have expressions that are involving polynomials. Expressions that are involving polynomials. So if I have x squared minus 2x minus 15 over x squared minus x minus 12. Now someone was already starting to ask this, does it matter what's in the numerator? It does. You have to ask yourself, can I factor the numerator? Can I factor this? Can I factor the denominator? Okay, can I factor this?
No.
Can I factor x squared minus 2x minus 15? Riley, can I factor that?
Yeah.
What am I looking for then?
So it's on the denominator, right? On the numerator.
This numerator. What am I looking for if I'm going to factor this?
Add to -2, multiply to -15.
Excellent. We're going to multiply to -15 and add to -2. What multiplies to -15 and adds to -2?
It's like, what has to be like 3? Yeah. Yeah, 3 and -5.
3 and -5. Good. So this would be x minus 5. And then x, you said 3. X plus 3. Okay, excellent. Okay. So we factor the numerator. What do you think we're going to do next, Jaden? We're going to factor the denominator. So if we're going to factor the denominator, what are we looking for? What are we looking for there, Logan? We're going to factor that denominator. Come on, we're factoring this. Joel already told us this one. We've done this. If you're factoring this trinomial, we've done this before. You have to know how. Come on, you can do it. Wake up. We look at that. There's no common factor to factor out of it. There's no x in each one. It's a trinomial where the leading coefficient is 1. What do we do with this? We've learned it in chapter 9. Perfect. There you go. That's what I'm trying to get you to start thinking like this again. Because it wasn't like I just taught that for nothing. You could use a quadratic formula too. Negative b plus or minus square root of b squared minus 4ac over 2a. You could use that, but you don't need to when it's an easier one with a leading coefficient of 1. So what multiplies to negative 12 and adds to negative 1? Negative 4 and 3. So we just write down x minus 4, x plus 3. Now notice this. Notice I have an x plus 3 over an x plus 3. Do you want to go out there and join them? Then I would be way more paying attention to what we're doing right here. Notice I've got an x plus 3 and an x plus 3. That's just like something over itself is 1. These cancel each other out. Okay, so we're looking for binomials or the identical things that cancel each other out. X plus 3 over x plus 3 is the same thing as 1. 5 plus 3 over 5 plus 3 is 1. So they cancel each other out. Then I'm left with x minus 5 over x minus 4. What is my excluded value? What's my excluded value? Jasmine? 4. Yeah, 4 minus 4 is 0. So my excluded value is 4. So it simplifies to x minus 5 over x minus 4. And the only thing in this whole world that wouldn't make that true is 4. Yes, sir?
What's the point of factoring this?
the reason why I had to factor the top is that I would have said an excluded value would have been 5 by just doing this, or excuse me, 3. But 3 actually works. If I put 3 into this equation, it will work. It won't, it's not an excluded value. So you have to factor the top in order to see that they cancel each other out. Okay? It's a good question. All right. So finally, we could have a problem that looks like this. 4x plus 16 over x squared minus 5x minus 36. So if I have a problem like this, what I'm always asking myself is, can I factor? Can I factor the numerator there? Can I factor that numerator? Is there anything I could do to factor that numerator? I see a couple heads shaking up and down. What could I do to factor that numerator? Not everyone at once here. Jacob.
You can take a 4 on 4x and plus 16.
We can factor out a 4. That's going to be x plus 4. You can divide this by 4 and this by 4. That's factoring. It's just what's the opposite of the distributive property. It is the distributive property, but okay. Now, what are we doing here to factor the denominator? Sam?
See what multiplies with negative 36 times negative 5.
Good. What do you know what that is?
Four and negative 9.
4 and negative 9. Okay, now you see why we factor this, the top part. Notice I've got an x plus 4 and an x plus 4. Those cancel each other out. There, it's just like 5 over 5 equals 1. This is 1 over 1. Okay, so now I've got 4 over x minus 9. And that is simplified right there. That's the simplified expression. What's the last thing we need to do? What's the last thing we need to do? Caitlin, what's the last thing I need to do here?
Simplify.
It's already simplified. It's kind of the new topic of what we've learned today. Brendan? Find the excluded value. Okay? It's just, you just have to figure out what makes it that it's not true. Excluded value is is 9. So that's simplified. That's the excluded value from this problem. Okay? That's all I have for the unit, for the lesson. Now I want to give you your assignment. Is 4 through 13 odds, 24, excuse me, 6, I don't know why I said 4, about 5 through 13 odds, and then 17 through 41 odds. Oh, that probably helps, right?
Holy moly, why?
Page 651. Work time. I do expect you to do this now. Focus on your work. Use the algebra book in your book. And go ahead and get started.